Now I am going to present a formula for area of the sector of the circle and area of the segment of the circle. Before that, let us recall the definition of sector and segment of a circle. Now, area of a sector and a segment of a circle. Let us recall the definition of the sector and a segment of a circle. Sector of a circle is a portion of a circle bounded by two radii and an arc of a circle. And now you can see here in the figure this area bounded by two radii OA and OB and the arc APB. This area is called sector of a circle. And the shaded region in the figure 1 is a sector. Angle subtended by an arc APB at the center O is called angle of the sector, that is angle AOB. It is a theta. It is given by the symbol theta. And this portion OAPB is called a minor circle. You can see minor circle, and this portion is called a major circle, major sector. And now segment of a circle. What do you mean by segment of a circle? Segment of a circle is a portion of the area bounded by the chord and arc of the circle. And in the figure here, this is bounded by chord AB and arc APB, and the shaded region bounded by chord AB and arc APB is a segment of the circle. This segment APBA is called, what is that? Minor segment. And this is called major segment. Here onwards, whenever I say a sector or a segment, I mean they are minor sector or a minor segment only. With these definition of a sector of a circle and a segment of a circle, with these clear ideas, now I am going to present a formula for finding the area of a sector of a circle. Now you can see here, let OAPB be a sector of a circle at the center O, and the radius R and angle subtended by the arc of this sector be theta, angle AOB be theta. Now you can see the figure here, radius is R, angle subtended by APB is a theta, and this is the center of the circle. We have to find out the area, formula for area of this sector OAPB. Now, we know that the area of the circle is a 5r square. Thus, if we consider whole circle as a sector, then the angle of this sector is 360 degree at O. Now you can see here A and B are coinciding each other, means it is just going to be a single line, and this whole APB is going to be whole circle, and angle subtended by this whole circle is at the center is 360 degree. And now, therefore, when the degree of a sector is 360, then the area of the sector, I mean whole circle, is equal to, I would like to write down 5r square. In this fashion, I would like to write down the same thing as 360 by 360 into 5r square. The same one I have written for the sake of convincing you about the sector of the circle, area of the sector of the circle. I have written in this fashion. When the therefore, when the degree of sector is 1 degree, then the area of the sector, instead of here 360, let me write down 1 degree by 360 degree into 5r square. 5r square. And therefore, the degree for 360 degree, 360 by 360 into 5r square, that is the area of the whole circle. When the degree of a sector is 1 at the center, then the area of the sector is equal to 1 by 360 into 5r square. And therefore, the degree of a sector is theta, then the area of the sector is theta by 360 into 5r square. Now observe, from this 360 by 360, when the sector is a whole circle and the sector at the center making a 1 degree, that is a 1 by 360 into 5r square. When the degree of a sector is a theta, then that is going to be theta by 360 into 5r square. And therefore, the area of sector this is equal to theta by 360 into 5r square. This is the formula for finding the area of the circle, which makes an angle theta at the center. Having found formula for the area of the sector of the circle, now I am going to present the formula for length of the arc of the sector. Now you can see here length of the arc of a sector. Now, as above, if we consider the whole circle as a sector, then the angle subtended by this sector, that is circle, is a 360 degree, whose length is perimeter of a circle, that is 2 phi r, that is 2 phi r. And now, thus, if we consider arc of a sector subtends an angle theta at the center, then the length of the sector is equal to what is that? Length of the sector at the center is equal to theta by what is that? Theta by 360 into 2 phi r. Because earlier, which I can write down 360 as earlier in the case of area, I have written 360 by 360 into 2 phi r. And similarly, the angle instead of 360 whole circle, if you are going to take the angle to be theta, then we have theta by 360 into this, that is theta by 180 phi r. This is the formula for the length of the sector. And the area of this segment, from the figure 5 here, area of APBA. And for this, how to find out the area? Now you can see area of segment APB equal to area of a sector OAPB minus area of a triangle, this area of a triangle. And now we came to know that to find the area of this segment is easy to find out that because we know the formula for area of the sector, and also we have to use the formula for finding the area of the triangle, and that equal to area of the sector is what is that? Theta by 360 into phi r square minus area of a triangle OAB. Note further that area of a major sector OAP, Q, let us say this is Q, equal to phi r square minus area of the minor sector, and also area of the major segment is equal to phi r square minus area of the minor segment, and thus we have found that the length of the sector and area of the segment and area of the sector, where we have given the formula for these ideas.